what seems to have happened here?
A mathematician was murdered!
So, we're trying to find the murderer?
We already found the murderer. We just need to find out what the murderer is after.
Let's go inside and see what the mathematician was really up to. Look, Watson, it looks like the mathematician was looking at a park. And look at what's on his desk. A circle that just matches the circle of the park. Maybe if we find the measure of angle 1, we'll be able to find whatever he was looking at. For these questions, all you need to know is the information given in section 10.5, which is applying other angle relationships in circles. People usually get confused about these types of questions because they forget the theorems, but all you have to know for this question is that the measure of the angle is 1/2 of the measure of the arc. And so we just have to plug in what we know. AB is 130 degrees, and the measure of angle 2 is 115 degrees. And then we solve. 130 multiplied by 1/2 or divided by 2 is 65 degrees, and 115 multiplied by 2 or divided by 1/2 is 230 degrees. After drawing the angle, we know exactly where to go. You see all of these circles? A mathematician would love this. The diagram brought me here, but what am I supposed to do now? Wait, what's that? This is the problem I found inside of the tunnel. A lot of people have trouble with this kind of problem because they always forget that you have to add when two chords intersect inside of a circle. We have to use the angles inside the circle theorem and this equation to solve this problem. We already know DC is 80 degrees and we know AB is 40 degrees. So we add them together to equal 120 degrees. And then we divide by 2, so the measure of angle 1 is 60 degrees. Now using this and other measurements that we found inside of the tunnel, we can find where we need to dig and where his secret will lie. It should be about right here. Look, this piece of paper was stuck on the back of the safe. Maybe it will lead us to the clue to open the safe and reveal the secret. These are the problems that were found on the paper. A lot of people have trouble with these kind of problems because they always forget that you have to subtract the measures of the arcs. You have to use the angles outside the circle theorem. First, we'll start with these two. BC is 220 degrees, AC is 80 degrees, DEF is 247 degrees, and then the last one, arc DF, is 113 degrees. Then 220 minus 80 is 140, and 247 minus 113 is 134. After you divide by 2, the measure of angle 1 is 70 degrees, and the measure of angle 2 is 67 degrees. You also have to use angles outside the circle theorem for this one. First, plug in what you know. Angle 3 is 34 degrees, and the measure of HG is 44 degrees. Then, you multiply 34 by 2 to get 68, and you add 44 to 68 to get rid of the negative 44, so that the measure of arc IJ is equal to 112 degrees. The paper says to always choose the smallest. I believe what that means is that we have to choose the smallest answer that we got for our password. So our password should be 67. Here it goes. Whoa, what's in here? It looks like it's a new theorem for circles.
Miss Holmes, how did you find all the angles in order to be able to solve the mathematician's new theorem for circles?
Let me tell you. Once upon a time, a fierce tweet. But then my teacher came and sat next to me, and she made me realize it's all really easy. It's finding all the measures is easy. Just remember these theorems and your equations will run smoothly. Add or subtract if they're on the end or outside. Don't forget you'll always need to divide. Don't hide, just tangents, secants, and chords. Oh, oh, it's not trouble, trouble, trouble. Oh, it's not trouble, trouble, trouble. If a tangent and a chord intersect in a dark arc, then the measure of the angle formed is half. It's intercepted arc, it's intercepted arc, it's intercepted arc. Two chords intersect, then the measure of your jingle is half the sum of the measures of the arcs. Intercepted by the angles, intercepted by the angles. Secants and their tangents intersect on the outside, and the measure is half the difference of the intercepted arc sides. Finding all the measures is easy. Just remember these theorems and your equations will run smoothly. Add or subtract if they're on the end or outside. But don't forget you'll always need to divide. Don't hide, it's just tangents, secants, and chords. Oh, oh, it's not trouble, trouble, trouble. Oh, oh, it's not trouble, trouble, trouble. The saddest fear comes creeping in. Everyone forgot to divide the outside angle question. Finding all the measures is easy. Just remember these theorems and your equations will run smoothly. Add or subtract if they're on the end or outside. Don't forget you'll always need to divide. Don't hide, just tangents, secants, and chords. Oh, oh, it's not trouble, trouble, trouble. Oh, oh, it's not trouble, trouble, trouble. Finding all the measures is easy. It's not trouble, trouble, trouble. Just remember these names and your equations will run smoothly. It's not trouble, trouble, trouble.